Hey, what's up, everyone? Welcome to my YouTube channel. I hope you guys are doing absolutely great. We are, as discussed in the last video, we'll be starting with a JavaScript series. We'll be starting with the basic fundamentals, JavaScript fundamentals. First of all, let's talk about JavaScript. What is JavaScript? So JavaScript is basically a scripting language which powers your HTML pages. So the reason why your HTML pages looks responsive is because of JavaScript. The another thing is it's a high level programming language. So to high level programming language. To all of you guys who are not familiar what is high level programming language, so there are two types, high level and low level. So high level programming language is something which human can read, and a low level programming language is something which a machine can read. Definitely we'll be talking about a high level programming language, what we can read. So this is a high level programming language. It's a combination of interpreted and a compiled language. We'll talk about what interpretation and what compiling is later on. But in a nutshell, it's a high level programming language is single threaded by default. What is single threaded? Single threaded means no parallel execution. No parallel execution, just single threaded, just synchronous execution, one after the another. But JavaScript supports asynchronous execution. That does not mean it will run tasks parallelly. Asynchronous execution is something which we'll talk later on. This is something which makes JS powerful, I would say. This is something which makes JS powerful. Now you might think that it is a single threaded language, that is no parallel execution, then how can it be fast? But asynchronous is something which makes JavaScript powerful, which makes JavaScript fast, and which makes JavaScript scalable. Then apart from this, JavaScript is dynamically typed. Sorry for grammatical mistakes, my bad. But JavaScript is dynamically typed. That is, you don't have to specify the variable types. Now I am hoping that you guys might be knowing what is variable and what is threading and what is variable, because these are like absolute basics. But what I want to say over here in a nutshell is JavaScript is dynamically typed. You don't have to specify the variable types. JS determines it at runtime. So if you guys are coming from the Java background, you guys might be knowing that Java compiles first, converts it into bytecode, and that bytecode runs on the native machine, right? JavaScript it kind of does not pre-compile things. It interprets things, that is, during the runtime itself. JavaScript executes the code, run it on the native machine. That is the one reason why JavaScript can break during runtime. It can break during runtime. You can get couple of errors if you mess up. So that is one problem. And talking about dynamically typed, since we don't have to specify the variable types, it may happen that you might mix up some values where you have to return integer, you might return string, and this can cause problems later in the code, where you were expecting integer but you are getting string. So that problems can happen, and that is the reason why TypeScript was introduced. TypeScript is nothing but, you just specify the types, nothing else. That is TypeScript. But we won't be talking about TypeScript. We will be looking into vanilla JavaScript, pure JavaScript, nothing else. Initially, browsers were designed to run HTML pages, static HTML pages. Static HTML pages are pages with HTML and CSS design. So static content plus design, static pages. But as browsers also evolved, later on new capabilities were added in the browsers so that they can also support dynamic rendering. Dynamic rendering in the sense pages no longer are static. You can change the things dynamically on the pages, like click on a button, change the color. So this is like, dynamically changing the contents on the page. So for this, it was very important to have something that can run the code on the browser, that can, think logically. So Google came up with its V8 engine. So V8 engine is something which executes JS on the browser. So in short, if I say V8 engine is responsible for executing the JavaScript. So basically what V8 engine does is, like, let me just take a new page. So what V8 engine does is, V8 engine will convert our high level programming language, that is JS, into machine code, which can run on our machine in the sense in our CPU understands machine code. So V8 engine is the one which interprets our JavaScript code. Interprets means converts the code into machine code which can be executed on the CPU. So this is the very high level understanding of what V8 is doing. There are n number of things what this engine does, but in short, V8 engine is responsible for executing the JavaScript on the browser. Plain simple. So since we know what JavaScript is, let us get familiar with the syntax. I am hoping that you guys might be knowing some idea about what programming and syntaxes and all. So basic JavaScript syntax looks like this. You define a variable using let suppose x is equals to some name, suppose first name, with a semicolon. Then we may have some function. We specify function, suppose name of the function, do something, accept some parameters, and curly braces define the function code. It defines the function code. That's it. This function can have statements, n number of statements. It can have it can do some mathematical operations. Some logical operations, and whatnot. Everything it can do. And at the end, you have the function call. This is defining a function. So we have defined the function, definition of the function in this sense, what the function is going to do, and this is the function call. This is the function call basic. Now let's understand how this function code gets executed on the V8 engine and what happens. And this is not only in terms of JavaScript, but in terms of any of the programming language. This is a basic theory what happens when the function runs. But we'll talk in terms of JavaScript. So we have something called as call stack, and we have something called as heap memory. We have call stack and we have heap memory. So if you guys do not know what is stack, stack is something called as last in first out. There is something called as first in first out. Let me explain what is last in first out and first in first out. Suppose we have an array. What is an array? An array is a collection of values like 1, 2, 3, 4, 5, correct? An array is a collection of values 1, 2, 3, 4, 5, etc. This is the end position of the array. This is the start position of the array. In a stack, there are two things. There is a stack and there is a queue. Queue we know, queue on the railway station, queue on the ticket counter. So what is queue? Queue is like something like you come first, you go first. First in, first out. And what is stack? Suppose stack of books. What is stack of books? There is a bookshelf. You keep one book and this part is open. You keep one book, then you keep another book, then you keep third book, then you keep fourth book. Now if you want to take books out, you'll pick this book first, right? Then this, then this, then this. So this was added last. But this is removed first, last in, first out. Simple. In terms of array, this is the end. If I want to add 6 over here, the 6 will be added over here, not here. It will be added over here. And if I have an array or a data structure, such that it can hold values, but it can add values at the end and it can remove values only from the end. That is basically called as a stack. So I can add values at the end, I can remove value from the end. This is called as a stack. In arrays, generally you can add a value at the end and you can remove value from the end. You can't do it from the first position. That's another topic altogether, but this is what arrays are. And in a queue, assume queue is also same. Don't get confused with this square braces, but queue is different. It's not like an array, but it is also a collection of values. But in a queue, you can add the value. You can basically remove the value from the starting position. Like a new value will come over here, but you can remove the value from the starting position. So values will enter from here and it will get removed from here. For now, we are not interested in queue. We are just interested in stack. So you understood stack. Stack is last in first out. You add something at the last, that will be removed first. So this is a stack. And what is heap? So heap memory is something, it is actually an expandable memory. Expandable, unorganized memory in your RAM. Why expandable? Why unorganized? Because that is what heaps are. They are expandable, they are unorganized, and heaps are the best places for storing the variable values, like whatever variables I'm using, whatever objects I'm using. So I hope you guys might be aware about JSONs. JSON is a key value pair, key value, key colon value, key colon value. So JSON is a key value pair. These are in general called as objects. Objects is anything that is not primitive. We'll talk about what is primitive, but in general objects, everything, it's stored in the heap memory. So you can say heap memory is something which stores the program data, which is the program that is currently getting executed. If this program is getting executed, the objects will be stored in the heap memory. We'll talk about what are objects and all later, but just understand this thing. Whenever the program is running, the data is basically stored in the heap memory for fast retrieval so that the program can access the data quite easily. So that is heap memory. It's quite important. Call stack is, and we understood what is stack, and we'll understand what is call stack. Call stack is basically used for storing the order of execution of the statements. Sorry for my handwriting, absolutely. But call stack is something which is used for storing the order of execution of the statements. Let's see what it is. So basically, let's understand if this is the function. Let name1 is equals to, suppose, John, and I have a function do something, function parameters. This function has let last name is the variable name, is Smith, and I'm having console.log. I'm printing something on the UI now. This is John, console.log, last name, oh sorry, not John, this will be referenced by name1, and this is last name, and here I am calling this function do something. So what is happening over here? We are defining a variable name1 as John. We are defining a function do something. Do something function has last name Smith. Console.log is basically used for printing anything on the console, console, terminal, anything you can call. So basically it's in the output window, in short. So it is used for printing, and this is like the function call. Now call stack will store the order of execution. Like first this statement has to be executed, then it will come to this function, then it will come over here, do something. So this function, there is a function call over here. So compiler will go over here. It will come to this function, then this statement has to be executed. This console log has to be executed. All this information will be stored in call stack. It basically stores which function has to be executed next. If there is a return from any of the function, then where I have to return back. Everything is basically stored in call stack. Let us understand more what is call stack and how the statements are executed basically in the call stack. Let us again go from our example. We have let the variable name is first underscore name as John. Then we have a function do something, and we have another variable let last name as Smith, and I have a console statement, printing statement, console.log name as we'll have this name over here, and we'll have first name, and we have console.log last name and we call this do something function. So how the statements are executed in the call stack, let's understand. What happens, let's suppose this is a call stack. So when the compiler basically comes over here on the first line, so it will store the value of this first underscore name as equals to John in the call stack. And then that compiler will come over here, and then my compiler will come over here and it will say, okay, there is a function call, do something. Okay, so it will register a function call over here, do something. Then then it goes to this function definition, do something. It says, okay, let last name is equals to Smith. So it registers last name is equals to Smith. And then there is a console statement, name is equals to first name. So this console statement comes over here, console.log. Now the statement will get executed. Remember, once the statement is executed, it has to be removed from the call stack. So everything is being added into the call stack from the top. So there is a console statement which is referring to this first name variable. Now the compiler will go and check where is the first name variable. It will check, okay, it finds the first name variable as John. So on the output, we'll have something called as name equals John, and the statement will be removed, popped out, removed from the stack. Then another statement will come, console.log last name this. So that statement will come, console.log last name. So the compiler will check where is this last name variable defined. It will find over here Smith. So it will output as last name is equals to Smith, and then this statement will be removed. There are no other statements in this function block. So now the last name, this statement will be removed, this statement will be removed. It will come back over here because it has the reference over here. So it will come back to do something. Then it will execute all the further code. First name will remain as it is as of now because the context for the global function is still active. I will explain what is the global context. The context for first name is still active. Context for do something was over. So do something function call was over. There were no other statements. So the context for do something has to be removed from the call stack. So everything related to do something was removed from the call stack. But the context for first name, because the code is still executing, there might be some statements or some lines of code after do something. So that's why we need the first name, reference to first name still active. So first name will still be there and another statements will then come in the call stack. And that is a simple way of how call stack executes. Now, this was the very high level understanding, but let me tell you what happens first of all. So when the code executes, the JavaScript code executes, it doesn't directly insert first name over here. There is a global context, something called as global context. Global context means the code that is getting executed outside this function over here on the top level, where do something function definition is present, where first name variable was initialized. That is a global context. Now what this global context has. This global context has first name and first underscore name definition. So global context knows that with the variable name first name is equals to John. Okay. And there might be other variables declared over here. So global context knows that. Then there is this function call, do something, correct? We come over here, there is this do something function call. Now understand, this variable last underscore name, I cannot use this variable outside this function call. I can only use this within this function call because this variable is a block scope variable. This is defined inside this block. It's a block scope variable. So this variable will be accessed only within this function, do something. So whenever there is a function call, what happens is a stack frame is inserted for this specific function. which will have the context only of this function. Context in the sense that stack frame knows that last underscore name is equals to Smith, and if there are any other variable initialized over here within this do something block, this stack frame basically will have idea about that. So this is the stack frame. Stack frame is basically a frame just for this function. Whichever function is getting called, for that particular function, a particular stack frame will be created. That stack frame will have the variable definitions and everything related to that function. Okay, let me just draw another stack over here. So as I said, there will be a global context which will have context of all the variables defined outside the function. Above it, there will be the stack frame. Now what happens is, like, when I call the do something function, inside this stack frame, last underscore name will be initialized to Smith, correct? Then there is a console log statement. A console log statement comes over here, console.log. A console log statement will come over here. In that console log statement I'm referencing to first underscore name variable. So my compiler will keep on checking. It will not find first underscore name inside the stack frame. It will go out of the stack frame, check in the global context if first underscore name variable is present or not. If it finds that particular variable present over here, then it will take it from the global context and it will print John, which is being happening in our case. Then we have console.log last name equals last underscore name. So this console log will be removed. Then a new console log will come over here, referencing last underscore name is equals to last underscore name. So this console log is checking for last underscore name variable. So it will check first in its stack frame. It will find last underscore name defined as Smith, and it will print last name as Smith. Well, what I can do is I could have also overridden the first name variable to something else. Maybe anything, maybe Emma, anything. So what would have happened is, when I'm printing this first underscore name, my compiler will check, first of all, it will check the stack frame of this function. This thing, it will find first name over here because first name is also defined within this function. So first underscore name will be present in its stack frame also. First underscore name is present in global context also, but compiler will first check if the particular variable is present in its own stack frame first or not. That is a simple thing what compiler does. And at the end, when there are no other statements in this function, then what compiler does is it will basically remove the entire stack frame for this function. This entire thing will be just taken and removed from the call stack, and next statements will be added into the call stack. So first underscore name, last underscore name, when removed from the call stack, it is lost. Once the function executes, then first underscore name, last underscore name will be lost forever. But first underscore name John will stay in the global context as long as the global context is active. That means as long as my compiler is executing other statements below do something, my global context will be active. This first name will be present in the global context, but this first name for this stack frame, for this do something function, will be lost forever. Now there are some advanced concepts like closures, and we'll be talking about closures later on, what closures does, and how can we save, like this last name. As I said, this last underscore name will be lost forever when the stack frame is removed, but there is a way by which you can retain this value of last underscore name using closures. and we'll talk about that later on when we are talking about closures. But as of now, this is how simply the function executes. Now, you may ask, what if this first underscore name is not equal to John, and what if this first underscore name is equal to, let me just take this. What if first underscore name is equals to a JSON with a key, a value, comma, a key, a value? Or what if this first underscore name is an array as 1, 2, 3, 4? These things we generally call them as objects. Anything which is not primitive in the sense, if I'm saying let x is equals to 1, this is a primitive data type. Primitive in the sense our CPU knows how to process 1. 1 is basically defined as 0001 in binary, and CPU knows how to process 0001. Similar is the case with strings. If I'm saying let x is equals to John, this is basically converted into Unicode and then it is parsed. But at the end, this is also stored as binary numbers binary numbers internally, and CPU knows how to process binary numbers. But what about this complex data structures like this key value pairs or array or sets or anything which is not primitive, which CPU does not know? So what happens is, if first underscore name was this, and if I just show you the previous page, if first underscore name was indeed a complex data structure, then what would have happened in the stack in that case? That means where would have this value first underscore name stored in the stack? Because as I said, like this is stored in the global context, and last underscore name is stored in the stack frame. So in case of objects, what happens is, in the stack we don't store the actual value of the object. These objects are stored in the heap memory, from where they can be accessed easily, maybe at a memory location 1, 2, 3, 4. This memory location corresponds to this object. Now this is not as simple as I'm saying, but for now just assume this is what it is. Now this is at this memory location. So in my global context, first underscore name will not hold the actual value, but it will hold 1, 2, 3, 4. So when my compiler is accessing first underscore name, it finds out, okay, this is a memory location, not the actual object value. It goes to heap, find that particular object in the heap memory, and parses this object and shows it to the user. Simple. That is what happens when the variables are objects and not primitive. So we store the memory reference and not the actual value of the variables in the stack. So this is like simple explanation of what a stack is and what heap memory is. And this will be very handy when we will talk about closures, how closures work, because without this you won't understand closure. I mean, you can understand closure without this, but the problem is, if you know this, things will be pretty clear about what closures are, how closures are created, and what happens basically when closures are created, because closures is the most important topic in JavaScript, React, and Node.js. Without closures, it's impossible to understand anything, because everything happens because of closures over here. So yeah, that is all about call stack and heap memory, and we'll see you in the next video with the next topics. Thank you so much. Bye.